Good morning, my grade 11 students. We are now in our lesson for week 1 in the first quarter. I am Teacher Eleanor, your teacher in General Mathematics. If you are now ready, then let's start. Now, bring out your activity sheet and your module. Be sure that you are in a conducive learning venue. Prepare a sheet of paper where you can write down your notes about our topic. Since our subject is math, be sure to have your answer sheet. After learning how to represent real-life situations using functions, you need to learn how to evaluate functions. This is very helpful in solving real-life problems such as fare, matrices, salaries and wages, rental fees, and unit conversion problems. And in performing the operations of functions, apply the steps of performing the operations of algebraic expressions and the steps of evaluating functions. Rules of signed numbers and laws of exponents are also useful in our lesson. Today's learning competencies are: number 1, to evaluate a function. Number 2, to perform addition, subtraction, multiplication, division, and composition of functions. And number 3, to solve problems involving functions. Okay, let's begin. Let f and g be the two functions. For any ordered pair xy of a function f, f of x is equal to y. The value of f at x equals y, which means that in evaluating a function, you just substitute the value of x and then solve for the value of y. Let us have the given examples. Number 1, if f of x is equal to 3x plus 2, find f of 5 and f of negative 3. We just substitute 5 and negative 3 for x in f of x is equal to 3x plus 2. So we have f of 5 is equal to 3 times 5 plus 2. 3 times 5 is 15 plus 2 is equal to 17. So f of 5 is equal to 17. Then next, we have f of negative 3. So is equal to 3 times negative 3 plus 2. 3 times negative 3 is negative 9 plus 2. Then negative 9 plus 2 is, we have to subtract because they have unlike signs. So 9 minus 2 is 7. And then the sign of the greater number is negative. Therefore, f of negative 3 is negative 7. Example number 2. If f of x is equal to x squared plus 5x plus 3, find f of 1/2 and f of 3a plus 1. So we have f of 1/2. We just substitute 1/2 for x. So we have 1/2 squared plus 5 times 1/2 plus 3. And then 1/2 times 1/2 is 1/4. 5 times 1/2 is 5 over 2 plus 3. Then we have to find the LCD of 4, 2, and 1. So it is 4. 4 divided by 4 is 1 times 1 is 1. 4 divided by 2 is 2 times 5 is 10. 4 divided by 1 is 4 times 3 is 12. And then we add 1 plus 10 plus 12 is 23 over 4. Or we can change it as a mixed number. So we have 5 and 3/4. Then we have f of 3a plus 1. We substitute 3a plus 1 for x. So we have the quantity of 3a plus 1 squared plus 5 times the quantity of 3a plus 1 and then plus 3. 3a plus 1 times 3a plus 1 is equal to 9a squared plus 6a plus 1. We apply the shortcut in squaring a binomial. So we have 3a times 3a is 9a squared. 3a times 1 is 3a times 2, so we have 6a. Then 1 times 1 is 1. And then we apply distributive property. So we have 5 times 3a is 15a, 5 times 1 is 5, then you just copy positive 3. Then we combine similar terms, so we have 9a squared, and then 6a plus 15a is positive 21a, 1 plus 5 plus 3 is positive 9. We have also the following rules of operations of functions. We have the addition of functions. In symbol, we have f plus g of x is equal to f of x plus g of x. For the difference or for the subtraction of functions, we have f minus g of x is equal to f of x minus g of x. For multiplication of functions, we have f times g of x is equal to f of x times g of x. For division of functions, we have f divided by g of x is equal to f of x divided by g of x. Then the last one, the composition of two functions. In symbol, we have f circle g of x is equal to f of g of x. The compositions of functions, we have f circle g of x is equal to f of g of x. Functions can be combined to give a composite function, sometimes called a function of a function. Composition of function is done by substituting the entire function into the other function. Let us have some illustrative examples. The given are f of x is equal to 2x plus 3, g of x is equal to x minus 5, h of x is equal to 4x squared, m of x is equal to x squared minus 2x minus 15, k of x is equal to 7x plus 6, j of x is equal to 4x squared plus 3. Find the following. Number 1, f of x plus h of x. Number 2, g of x minus k of x. Number 3, m of x divided by g of x. Number 4, j of x times h of x. Number 5, k of 2 minus g of 1. Number 6, h of f of x. And number 7, m of g of x. And number 8, m of k of x. Then for letter B, the distance from San Fernando to Bangued is around 90 kilometers. Number 1, how long will it take you to get to Bangued if your average speed is 15 kilometers per hour, 30 kilometers per hour, and 45 kilometers per hour? Number 2, construct a function S, where S is the speed of travel that describes the time it takes to drive from San Fernando to Bangued. So we have the solution. In number 1, letter A, we have f of x plus h of x. So we just substitute the given value of f of x and h of x. So we have the quantity of 2x plus 3 plus the quantity of 4x squared. So it is equal to 4x squared plus 2x plus 3. This is the sum of f of x and h of x. Number 2. G of x minus k of x. Again, we substitute the values of g of x and k of x. So we have the quantity of x minus 5 minus the quantity of 7x plus 6. So we have x minus 5 and then negative 1 times 7x is negative 7x. Negative 1 times 6 is negative 6. And then we combine similar terms. X minus 7x is negative 6x. Negative 5 minus 6 is negative 11. Then number 3. M of x divided by g of x. So we have to substitute the given values of m of x and g of x. So we have x squared minus 2x minus 15 divided by x minus 5. So by using long division, or we have the long method in dividing a trinomial by a binomial, so the quotient is x plus 3. But if we treat the given as rational algebraic expressions, we are going to factor x squared minus 2x minus 15 as x minus 5 and x plus 3 over x minus 5. So we can cancel x minus 5 and x minus 5. So what is left now is x plus 3 over 1, or simply x plus 3. Then number 4. J of x times h of x. So we substitute the values of j of x and h of x. So we have the quantity of 4x squared plus 3 times the quantity of 4x squared. Now we apply distributive property. 4x squared times 4x squared is 16x raised to the 4th power. 4x squared times 3 is positive 12x squared. And then number 5, k of 2 minus g of 1. So we have to substitute the value of x, which is 2, in k of x. So we have 7 times 2 plus 6. And then we also substitute g of 1. So instead of writing x, you will write 1 for g of x. So we have 1 minus 5. Okay, then next we have 7 times 2 is 14 plus 6 minus the quantity of 1 minus 5 is negative 4. And then 14 plus 6 is 20. Negative 1 times negative 4 is positive 4. 20 plus 4 is positive 24. And then in number 6, h of f of x is equal to 4 times the quantity of 2x plus 3 closed quantity squared. In h of f of x, it means that we will get the value of h of x wherein your x is the value of f of x. So we will just substitute f of x as 2x plus 3. So we have 4 times the quantity of 2x plus 3 closed quantity squared. Then 2x plus 3 times 2x plus 3 is equal to 4x squared plus 12x plus 9. Applying the shortcut method in squaring a binomial. And then times 4. Okay, then we apply distributive property. 4 times 4x squared is 16x squared. 4 times 12x is 48x. 4 times 9 is 36. Number 7, we have m of g of x. This means that we will get the value of m of x wherein our x is the value of g of x. So we have to substitute g of x squared minus 2 times g of x minus 15. Then we substitute the value of g of x as x minus 5. And then we square now x minus 5 and the result is x squared minus 10x plus 25. Then we apply distributive property. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10 minus 15. Then we combine similar terms. We have to copy x squared and then negative 10x minus 2x is negative 12x. 25 plus 10 is 35 minus 15 is positive 20. The value now of m of g of x is equal to x squared minus 12x plus 20. Number 8, m of k of x. So we substitute again the value of k of x in m of x. We have the quantity of 7x plus 6 closed quantity squared minus 2 times 7x plus 6 minus 15. Then we square 7x plus 6 and the result is 49x squared plus 84x plus 36. Then we apply distributive property. Negative 2 times 7x is negative 14x. Negative 2 times 6 is negative 12 minus 15. Then we combine similar terms. So we have 49x squared. 84x minus 14x is 70x. 36 minus 12 minus 15 is positive 9. So the value of m of k of x is equal to 49x squared plus 70x plus 9. For letter B, the distance is calculated as the product of speed and time. So we can get the time by dividing distance by the speed. 90 kilometers divided by 15 kilometers per hour is equal to 6 hours. 90 kilometers divided by 30 kilometers per hour is equal to 3 hours. 90 kilometers divided by 45 kilometers per hour is equal to 2 hours. Since time is the quotient of distance and speed, we can write out the function as t of x is equal to d over s. The distance is fixed at 90 kilometers, so the final function we have is t of x is equal to 90 over s. You may watch a video clip about operations of functions at this link to deepen your understanding. Now, let us see if you remember our lesson for today. Number 1. How do you perform addition, subtraction, multiplication, and division of functions? State the steps in your own words. And number 2, what is composition of functions? How do we perform this operation? Write your answers in your notebook. That is for today. I am glad that we finished 3 learning competencies from our lesson. Now that you have learned how to evaluate functions and perform operations of functions, continue doing the following to enhance these skills. Work on Activity 1, letter A only on page 2. Activity 2, numbers 1 to 10 on page 3. And Activity 4 on page 5 of your learning activity sheet. And do Activity 2 on pages 9 to 10. What I can do on page 17, numbers 1 to 3 as your performance task, and post-assessment numbers 1 to 15 on pages 13 to 14 of your modules. I hope you learned a lot from our discussion. Once again, this is Teacher Eleanor. I will end my topic with this motivational quote from Les Brown. You must tell yourself, no matter how hard it is or how hard it gets, I am going to make it.